Okay, we're in section 26 and we're going to do the homework. I'm going to switch over to the whiteboard. Okay, first question. It says, find the coordinates of the particle following the given path at the requested times. Okay, so x is a function of t and y is a function of t, and they say t is equal to 0. So let's write this down. So it's going to be x evaluated at 0. That's going to be -8, and y evaluated to 0, and that's going to be 1. So what's the coordinates of the point? Coordinates of the point would be -8 for x, 1 for y. All right, let's go to the next page and see if they got that answer written down there, and they do. Now they say t equals 1, so x evaluated at 1, fairly simple. And remind myself of the function, it's 4t squared minus 8. That's going to be -8. I'm sorry, not -8, it's 4 minus 8. My mistake. Let me go backwards. 4 minus 8, which is -4. And y is also a function of t. And what's that function? It's 4t cubed plus 1. So y of 1 would be, let's see, that would be 4 plus 1, and that would be 5. What's the point going to be? -4, 5. All right. All right, t at 2, let's put this down, x2, relatively simple question. Again, to remember, it's 4t squared. So it's going to be 4 times 4, which is 16, -8, which is 8, and y of 2. And that's going to be 4t cubed. So that's going to be 4 times 8, which is 32, plus 1, which is 33. So the point is going to be 8, 33. Let me see that right over here. All right, let's do number 2. Number 2, reading to, it says a bullet follows this trajectory. It says show that the path traced by the bullet is a parabola by eliminating the parameter. So I know that x is a function of t, and that turns out to be 80t, and y is a function of t, and that's 600 minus 16t squared. So I'm going to write down x equals 80t, and I'm going to write down y is equal to 600 minus 16t squared. We're going to limit the parameter by making a substitution over here. And I'm going to say x over 80 is equal to t. I'm going to plug it in up here. What do you get? Y equals 600 minus 16 times t squared. Well, t is x over 80, so that square is going to be x squared over 80 squared, which is 80 times 80. I'm going to simplify this. This is 600. Let's see, 16 goes in 80 5 times, right? That's 50 and 30, yeah. And then 5 times 80 is 400. So it's minus 1/400th of an x squared. This is certainly an equation of a parabola. It's a downward facing parabola, by the way. So let's take a look. And what they got over there? Whoops, I made a mistake. You know what I did? I copied wrong. And let's see what I copied wrong. Yeah, I copied something wrong. So I got to do the problem over again. And that happens all the time. All right, I'll tell you what I copied wrong. I copied y wrong. And let me copy it down. I'll do it again. And this is what you should do in homework. You make a mistake, do the problem again. So it's going to be 600, not just 600 plain, but 600t minus 16t squared. Well, second time through should be quicker. What's x? X over 80 is equal to t. I'm going to plug that in now. It's going to be y equals 600 times t, which is x over 80, minus, I know we just did it, by the way, minus 16. T squared is going to be x squared over 80 squared. And let's see if we can do that. So we get, let's see, 60 over 8. I'm doing some work over here on the side. So it's going to be, let's see, 15 halves. And I think you remember me doing this before. That's going to be 1/400 x squared, which is still an equation of a parabola. Again, a downward facing parabola. Next page, see if we got that. And we did. All right. Let's do this one over here. And they're kind of straightforward problems initially. It's probably going to get more difficult over time. But let's see. Express the given parameterization in the form y equals f of x. Let's put this down. So what do you get over here? I'm going to say, gee, x equals 5t plus 2 and y equals 2t plus 3. And I'm trying to eliminate the t in the problem. There's many ways to do it, by the way, many ways to do it. So I'm going to do it a little differently than I'm doing in the notes. What I'm going to do is, simultaneous equations, and let me write this down for you. So x, 5t plus 2, and then I'm going to write y equals 2t plus 3. So I'm going to try to eliminate the parameter, which is eliminating the variable t in the problem. And the way I do that is I multiply the top equation by 2 and the bottom equation by, let's see, minus 5. Let's write that down for you. And it's a little different than what's in the notes. This is 2x, 10t plus 4, and this would be minus 5y equals minus 10t minus 15. I'm going to add these together. You get 2x minus 5y is equal to minus 11. Okay. By the way, I want to look at their answer and go through this with you. Now, certainly, this is an equation of a line over here, but it looks like what they're doing is they're solving for y. And I'll tell you why they're doing that. If they're doing that, how do they do that? Y would now be a function of x. Let me go through that with you. So 2x minus 5y equals minus 11. Whoops. This would be 2x plus 11 equals 5y. And if you divide through by 5, what do you get? You would get 2/5 of an x plus 11/5, which is the answer they have staring over here. Now, I want to point out, they asked me to do that. All right. So, this is a good answer. They really wanted me to solve for y. All right. Y is a function of x. All right. Let's look the next one down. Same story. I'm looking at it and I want to eliminate the parameter. So I'm going to say x equals 9 over t. And I'm going to say y is equal to 7 over t squared. All right. So, again, the question often becomes, how are you going to do this? Well, there's many ways to do it. I'm not going to say there's only one way to do something, but in the other thing, we do want a function of x, and we want y to be that function of x. Let's take a look at it, and I'm going to maybe just do something that's different. I haven't turned the page yet, but I'm going to square both sides here. What do you get? X squared, and that's going to be 81 over t squared. All right. So someone says, why would you have done that? Well, what I'm going to do now is I'm going to multiply both sides by 7. 7x squared equals 81 times 7 over t squared. All right. So what do I get? I get 7x squared equals 81. And what's 7 over t squared? It's y. So now do I have my function? Not my function, but my relationship. This is a nice relationship to have. Can I solve that for y? Sure. What's y going to be equal to? 7 over 81x squared. And this is the function of x. All right. Let's go to the next page. I'm seeing that right here. All right. Relatively straightforward. All right, let's go to number 5. And again, it's really the same story over and over again. And I'm going to write x down. What's x? X is 16 t squared plus 1. And y is equal to 2t cubed. All right. Again, the question is, what are you going to do, or how are you going to do this? There are many ways to do it. All right. What I'm going to do here is the more traditional approach. I'm just going to solve one of these things for t. And I think the second equation is pretty easy to solve for t. What do you get? Y over 2 equals t cubed. And what would y be equal to? The cube root of y over 2 would be equal to t. Take this, plug it in over here, and let's write this down. What do you get? X equals 16. I got to square that guy. I want to point out this is the same thing as y over 2 to the 1/3 power. And if you square that, what do you get? You would get y to the 2/3 over 2 to the 2/3. Don't be discouraged. Plus 1. All right, I'm going to keep going through this. X equals, well, 16 is 2 to the 4th, right? And that's going to be 2 to the 2/3 on the bottom. I'll simplify that later. and then get y to the 2/3 plus 1. All right, let's keep going. It's more difficult. I realize that. What do you get over here? I got to simplify that. It's going to be 12/3 minus 2/3, 10/3. And then you get y to the 2/3 here. And what do I have to do now? Well, I got to subtract 1 from both sides and divide both sides with a coefficient on y, which is 2 to the 10/3. And that's going to be y to the 2/3. All right, a little complicated. I realize that. And of course, what I'm doing is saying it may require me to, rethink the problem. So what are you going to get over here? I'm going to cube both sides. What are you going to get? X minus 1 to the 3rd power. And then you would get 2 to the 10th power. Again, I'm cubing both sides. What do you get? Y squared. This one I get trouble, but I have to think about it. So before I think about it, what I'm going to do is write down y equals plus or minus. I'm taking the square root rule. It's going to be x minus 1 to the 3/2. And at bottom would be 2 to the 5th power now, which is 32. Now, before I go on about what I'm looking at, I want to go back to the original statement over here. And what I want to claim over here, it's really important that you look at this thing over here. And what I'm going to claim over here is that the x is always going to be greater than or equal to 1. The y could be any real number, by the way. All right, I'm going to go back over here, and I'm going to communicate that to you. I'm going to say over here, x must be greater than or equal to 1. Again, I want to look back over, make sure that that's okay. Yeah, it's okay. Okay, let's take a look at the answer. See how we did. All right, did we get the right answer? Plus or minus, yeah, I got that. X minus 1 to the 3 over 32. X greater than or equal to 1. All right, I'm going to read what I wrote down here. Make sure it's important that you understand why I said that. I hope you do understand that. And you keep in mind that the graph is parametric relation will be easier to identify if you know that x is greater than or equal to 1/2. All right. You know what I got to do is not really. I'm not going to graph that. They didn't ask me to do it. Next question. Oh boy, they're getting more difficult. And what I'm going to do is I'll write this down for you. X is the natural log of t over 9. And y is 5 plus 3t. Well, I'm going to write a little differently. I'm going to write down 9x equals the natural log of t. And then I'm going to write down t, and this may seem strange to you, is e to the 9x. I'm going to take this and substitute over here. What do you get? Y equals 5 plus 3 e to the 9x. All right. So let's take a look, see we got that. And we did. Wasn't so bad. Okay, express the given parameterization form by eliminating the parameter. Hint the trigonometric substitution might be useful. And let's take a look at that. And again, they say something might be useful. Who knows? So let's take a look at this over here. I'm saying x equals 4 cosine t. And again, they did make this reference about, something to do with squarings. So let's write this over here. X squared is equal to 16 cosine squared t. And we keep going. Y is equal to 7. Well, tangent is going to be sine t over cosine t. And y squared, right, would equal 49 sine squared t over cosine squared t. Again, I hope I'm not going too quick with that. All right, so what am I going to do now geez, I got to make a substitution over here. And this could get really nasty looking. And I'm going to say x squared over 16 is the cosine squared t. So I can write down y squared 49. And then the cosine squared t is actually just x squared over 16. All right. Then I got this sine squared business. And I noticed I wrote something over here that might be helpful for me. All right. So let me write that down. And what's it going to be? Well, this may be helpful, but sine squared is actually, whoops, I didn't mean to do that, is really 1 minus cosine squared. So that's going to be x squared over 16. Okay, let's keep going. And I'm going to do something that might look a little bit nasty, but I'm going to multiply top mine by 16. So I get y squared. The bottom is x squared. Then I get 49. This would be 16 minus x squared now. All right. I got to go back and remind myself what they're looking for me to do. Express the given parametric form by eliminating a parameter, hit, and use trigonometric substitution. Well, I think I can get there. Let me keep going. So what do you get over here? X squared, y squared, 49 times 16 minus 49x squared. Do they want me to write it as a function? No, I limit parameter. It's done. All right, let's see what they wrote down. Again, I don't think it's done there. And yeah, they wrote it as a function. I got to go through that now. So let me see if I can do that. So x squared, I'm sorry, not x squared. It's going to be, I'm going to divide both sides by x squared. Just give me 1 second to do so. So I'm going to go backwards again. Y squared, they're actually solving for y, by the way. Let me do 49 times 16. That's 490, right? Because 10 times 49 is 490. 6 times 40 is 240. And 6 times 9 is 54. Let's see, 9 and 9 is 18. That's 784. Oh, you know what? I don't want to do that. I'm going to factor out the 49. And what do you get over there? X squared here. And then you square root rules. What do you get? Y equals plus or minus the square root of that, which isn't so bad. It's going to be square root of 49 is 7. And then I get the root. This is the root of 16 minus x squared. And the square root of x squared, if you want to put the absolute value, you can, but x. All right. So let's take a look. I'm going to go to the next page. And I got it right here. All right, got the answer. Now, I want to point out they say x not equal to 0. Let me go through that. Before I do that, I want to point out, and again, I think it's not a simple problem to analyze, but I want to point out the x, I'm just looking at this over here, the x is between, all right? Now the tangent, you know, if I look at the y is between minus infinity and infinity over here, all right? But there is trouble over here, and the trouble over here is that the x can't be 0 in this analysis over here. Could it be 0 over here? Let's see. No, it couldn't be 0 there either. All right, but anyway, let's go back over. And again, it said, you know, the value of x has to be between plus or minus 4. This is stated and cannot be 0. I'm just reading my thing. Again, this is important if you need to identify the graph. What I mean by that in a standardized exam. We'll talk about graphing more later. And, you know, certainly some graphs are going to be easy to do, but I want to point out, you know, typically in standardized exams, they'll give you the relationship and then they'll put a bunch of graphs down and say, which one could it be? So what I'm going to do over here, if I were doing this one over here, you know, what I realize about this over here, I know what x is equal to. X is equal to 1 minus t. And I know that y is equal to t squared minus 9. So I want to claim what I do know about y. If I were looking at pictures, I know y has to be greater than or equal to minus 9. The x can be anything, by the way. So the x could be any real number, just looking at this. I want to eliminate the parameter though, and the way I would do that is I would probably try to solve x for t. So let's see, t would equal 1 minus x. Then I would plug this into the other one, which is y equals, well, t squared is going to be 1 minus x squared minus 9. And what's y going to equal to? Well, it's going to be 1 minus 2x plus x squared plus 9. And what's y going to equal to? X squared minus 2x plus 10. All right, I definitely noticed a parabola, by the way. So if I were looking at a graph, I would be looking for a parabola that opens up where the range of it starts at minus 9 and goes up. If there were multiple graphs down there, I might have a tougher time, but it's really not that bad. I mean, it's certainly not bad at all. So one thing you can do is just factor it. And what would that be? I hope I did that right. I think I made a mistake somewhere, actually. Now I see it. I made a mistake. And the reason I'm looking at the graph, and that's not the graph. So I have to erase. And let me tell you where I made a mistake. Right over here. Get that to make it erased. It was minus 9. Whoops, sorry about that. When you're doing homework, you make mistakes, you should correct your mistakes, erase it, and try again. It's going to be x squared minus 2x minus 8. And let me write this over here, y equals x and x. That would be 4 and 2, right? Minus 4 plus 2. So, I know it's a parabola. I know it opens upward, so it have an intercept at 4 and at minus 2. It would have a y-intercept at minus 8. And the vertex would be dead center on that one. So between that dead center would be here. You could also use the minus b over twice a that you learned in Math 100. So it looks like a good graph. All right, let's go to the next page. Whoops, maybe I should go to the next page. I didn't finish the problem. Oh, over here. More difficult question. So looking at it, what I do know about this over here, x has got to be greater than minus 4 or equal to it. The y's, I'm going to go through this with you. Something about the y's over here. The y could be any number at all. But again, knowing that x is greater than or equal to minus 4 is going to help me greatly. So let me write this down for you. X equals t squared minus 4, and the y is going to be 8t minus t cubed. All right. I got to be honest with you. So it's really, really difficult to do these problems over here. Let me just make sure that I read the question, understand it. And let me just see if I can go back to that question over there. So they say, graph each of the following. You may use a calculator, but you should be aware that many standardized tests expect you to identify the graph by looking at them. So I'm eliminating a parameter. I don't think it's going to be productive. I just don't think eliminating a parameter is going to be productive. So what I want to do is I want to talk about that if I were looking at graphs now, I would be looking for simple things. All right. And this graph is going to be X and Y. I'd be looking for simple things. So I know the X is starting at minus 4. I'll put this over here. All right. So when would that occur? Certainly, if I thought about it, when t is 0. Well, what would I'm sorry, I made a mistake there. When t is 0, what would the y be? It'd be 0. So I know I got a point here. All right. Now I'm going to keep moving around, and I'm going to say, what's another easy t to choose? I would say t equals plus or minus 2. Someone says, why do you choose that? Because x would be 0 then. So if x is 0, right, and I got plus or minus 2, let me write this down. So I know at plus or minus 2, x would be equal to 0. But what's the y going to be equal to? Well, if I chose 2, what I get? I get 16, right? 16. I'm going to choose t as 2, right? You would get, I just did it again. If t is 2, you'd get 16 minus 8, which is y is 8. Okay, so 0, 8. I got that down. And I'll put this over here. Now, if t were minus 2, though, again, x is still going to be 0. What would you get for y? That would be, let's see, minus 16 plus 8, which is minus 8. I'm going to point over here. And by the way, I'm not saying this is easy to do, but you do have an idea that, if you were looking at graphs now, you'd be looking for a graph of this over here. I do want to talk in a moment about using software. But before I do that, I'm gonna look at the y. I'm wondering, when does y become 0? Well, I'm going to factor it. It's going to be t, right? I want the y to be 0. When t, let's see, that would be 8 minus t squared. So when t is 0, I already knew about that. But it also occurs when t is plus or minus the root of 8, which is 2 root 2s, plus or minus 2 root 2s. So again, yes, someone says, why would you go through that? Well, I could get some more points now, right? So I know y is 0 at this place over here. Question is, what's x? Well, what's nice about that? Plus or minus 2 root 2s, what would I get? I would get 8 minus 4, which is 4. All right. So I get another point over here. All right. Now remember what we said. We said that y could be any number. And certainly, I think I've exhausted all the simple numbers. So I'll go to software later, but I want to look at the picture, and I'm seeing what I want to see. And so, what do you mean you see what you want to see? I see this, I see this, I see this, and I see this. I see that. The problem becomes for a lot of students is connecting that together, right? Connecting it together. But I gotta be honest with you, a standardized exam, this might be enough for you to understand the connection. I'm going to switch screens though. All right, I'm going to show you how to graph that. And I'm going to use a software to do it. Just give me a second to do a new share. And I got to do this for you. Let me scroll that problem. And you should be practicing using software anyway. So, I'm going to do number 5 for you. I'm going to go to my grapher software. And I'm going to plug this in. And my first is the x is going to be equal to 16 t squared. And the y is 2t cubed. I'm just playing around, 2t cubed. Now, by the way, I do want to change the range of, I'm going to say like from minus 10 to 10. All right, now I'm looking at it, and someone says, I don't know what you're looking at. I'm looking at a graph, and I hope you remember I said, let me see if I can zoom out of that. Did I make a mistake here? I did. It's 16, because I was looking at my graph and saying, I'm not expecting that at all. That's 1. Sorry about that. So someone's looking at the graph over here, and I realize the graph may not be to your liking. So I'm going to just simply change a few things about this. I'm going to get rid of the grid because it annoys me a great deal. So what I'm going to do is I'm going to zoom out a little bit. All right, and I'm starting to get a better idea. Now I'm actually going to zoom in to a region that I want to get over here. Now I have to be honest with you. A lot of students looking at this are going to misunderstand. That's what's known as an artifact of a picture. You understand it, you might think this thing touches 0 over here. But what I want to do is I want to start to zoom in to this region over here. All right. And someone says, I still can't see it. So I'm going to kind of zoom in, and I'm going to zoom in like this. All right. Now someone's going to say, I still can't see what's going on there. I'm actually going to remove the axes, but I want to keep in mind that this is where the number 1 is. All right. Let me remove the axis. And I hope you realize we said it's starting at 1. Do you remember that when we did the problem? Starting at 1 and going forward. Okay, so let's keep going. And I'll look at the problem that we were talking about before, how to graph those guys. I'm not going to graph this one out, not going to graph that one out. Let's take a look. I think we were over here, a graph of the parabola. I want to graph this one out though, and I want to show you what it looks like. And using a software, I'm going to equalize the axis, recenter the origin, and zoom out. And I want to display the axes again. All right. So give me 1 second to do so. I'm going to put the abscissa back. All right. So what I want to do is I want to graph out, and I'll tell you what I'm going to graph out over here. And again, playing with software is something you want to start thinking about doing, particularly if you're a computer science major or you're going into mathematics that's applied. All right. So it's going to be, I said t squared. Let's see, t squared minus 4, right? So, I certainly doing that. I know that the x has to be greater than minus 4. I'm clearly seeing that. And I think we told you the y could be any number in the universe. So 8t minus t cubed. And I'll do that. And I'm seeing a picture, and this was it's awful distorted. And I agree, it does look distorted. So someone says, why does this picture look so different? And I want to get that across to you. It's the scales that I'm using. We can change the scale of this, and the scale of this thing was changed. By the way, it's deceptive though. The scale along the y-axis is definitely different than the scale along the x-axis. You notice this is 4 units here, and this is 8 units here. So I really kind of distorted, not this picture. This picture is not distorted. I distort the one that was in the notes. Reason being is it just looked nicer to me. Keep in mind, you should know what scale is. If you remove the scale, that will be a problem for you. All right. So I'm going to, look at the next one, and I want to graph this one over here. But looking at it, I want to point out before I do anything, the x has got to be between plus or minus 1. I know that much. So whatever graph I produce, the x will be between plus or minus 1. So let's put this down for you. And again, we're using software, and I'm using a software package called Grapher. Whether you have access to this or not, doesn't matter to me. You should be considering using any piece of software that you like to use. And I'm hopeful that your teachers in the future will speak to you that way as well, that they want to make sure you're adult enough where you're getting these things over here. So I'm seeing that. And someone says, I wonder if that's the full picture. And, kind of looking at it, I want to claim to yourself that I really have to change the parameter t in the problem. And the reason for that, you notice that when I have to 10 or minus 10, the y is only taken on those values. And now I'm seeing that. And you can zoom out if you like. Let me just make sure you understand what I mean by that. And if I did that, this thing's going to stop at 100 over here. I'm going to zoom in and show you that. All right, you see it stopping at 100. Now, if I went to 105, watch what happens. Give me 1 second. It's going to go up to 105 then. And I hope you realize what we're doing. It's just playing around with the parameters. All right, let me recenter or equalize axis. And I'm going to center the origin. Okay, and I'm going to do the next one. And again, I'm looking at this thing, and what do I know? I know the x's are always positive. I'm looking at D now, and the cosine goes between plus or minus 1. So the x is always going to be a positive, I should say a non-negative number, and the y value is going to be plus or minus 1. So I'm going to do that one now. Again, I'm using software, and I'm encouraging its use, by the way. You're going to learn a lot about graphing by using software. So again, I said the x would be non-negative, and the y's would be between plus or minus 1. And let me show you what this looks like. All right, so remember what I said. The x is non-negative. I clearly see that. And the y values will be between plus or minus 1. Let me kind of zoom out for you, though. And I think you get an idea what's happening over here. I'm just going to zoom into this region. And I think you're getting an idea what's happening. All right, now someone says, could I graph that by hand? Yeah, you can graph it by hand, but it's kind of difficult. That's why we're encouraging use of software, at least on problems that require software. All right, let me do number E. I think E is going to be a lot easier to deal with. But again, it's a learning experience for a lot of students. And by that, what I mean is I'm looking at this thing. The x can be any number in the universe. That's 4t, right? plus 2, and we're just playing around with software. And and what's the y going to be? It's going to be 5 minus 3t, which again, any number in the universe is going to cover everything. I think you have a strong suspicion this thing's going to graph out, and they can look at it, and it graphs out as a line. I'll go back in the notes, by the way, and I'll talk through that. And let me see if there's anything else I want to do. By the way, scales are distorted greatly here. The scales are distorted greatly over here as well. And I got the line over there. Scales are distorted. I think I'm doing okay. All right, let me go back to the whiteboard now. I think we're done talking through the software. And let me go back to whiteboard. Okay. Again, the more time and effort you put into this, the better you get at it. There's no doubt about it. So let's go to the next page and I'll talk about the distorted scales over there. Let me look at number 9. Number 9 is a multi-part question. Give me 1 second. So it says a particle follows this trajectory, and it says where t is measured in seconds and distance is measured in centimeter. When is the particle at the ground? Well, it hits the ground when the function y, that's the height above the ground, by the way, because it's horizontal, it hits the ground here, when y is equal to 0. And let me write that down for you. That's 10t minus t squared. So I'm going to say t factors out, and that would be 10 minus t. So I'm going to say at t equals 0, it's on the ground, and when t is equal to 10. All right? So at 0, at time equals 0, it's on the ground. At t equals 10, it hits the ground. So clearly the thing is being thrown up, and then it's coming back down, hits the ground. So let's see what they said. There's 2 solutions, t equals 0, t equals 10. However, t equals 0 is the initial time. Well, what is that saying? We're starting at time 0. We're going forward, right? Initial time is 0, and we're going forward. So at 10 seconds, it hits the ground. All right, what's the next question? How far is the particle from the origin when it hits the ground? Well, how far is it from the origin? Well, it starts at the origin, it hits the ground at 10 seconds, right? So what's its distance over here? That would be the x-coordinate. So what's x at 10? I don't know. I got to plug that in. So it's going to be 1/4. 10 cubed is 1,000. We'll do the computation later. Plus, well, it's 3 times 10, which is 30. So it's going to be 250 plus 30, which is 280. And again, I think they're measuring this in centimeters, right? Yep, 280 centimeters from the origin. And that's right over here. All right, let's go to the next question. Oh, next question is different. Next question, what they do is they give me, this is an equation of a circle, by the way, and you should know that from Math 100. What does the equation represent? It's a circle with this has a center. Very simple, minus 2, 7. You learned about this in Math 100. It was certainly reinforced in Math 119 as well. And its radius is equal to 4. All right, so let's say an equation of a circle. Radius is 4, and I got the center right. They want to make a parametric function of this over here. And I'll be honest with you, something that can be very difficult and very convoluted. And I'm going to give it a shot. All right. And certainly I'm going to say something to do with Pythagorean identity. And what do I know? I know that sine squared, theta plus cosine squared theta is equal to 1. Now I'm not going to use theta. I'm going to cross that, and I'm going to try to use a parameter. Sine squared t plus cosine squared t is equal to 1. All right. Then the problem comes is, I hope you realize you want 16 out of this. So I got to write that down now. So what do I have over here? 16 sine squared t plus 16 cosine squared t is equal to 16, right? Well, I'm gonna write a little bit different. I'm gonna write as 4 sine t squared. Let's write this other guy down, which would be 4 cosine t squared is equal to 16. Well, now I think I see it. What do I say? I see this. I'll write this down. 4 sine t is equal to x plus 2. I see that. And what do I see over here? I see this is this up here. And what is that going to be? 4 cosine t is equal to y minus 7. I'm going to just, I'm not saying there's anything wrong with that, but I'm going to write this down as, let's see, I guess I'd write sine t is equal to x plus 2 over 4, and cosine t is y minus 7 over 4. I guess you could write that down. But really, I want to solve for x. Let's write this down. So what's x? 4 sine t minus 2. And what's y? Well, y is going to be 4 cosine t plus 7. So my parametric curve is this: 4 sine t. That's what x is. And what's the y? 4 cosine t plus 7. Let's take a look, see if we've done that. And did they do that? And yeah, they did do it, but they certainly didn't do it to the extent I did it. They stopped here. All right. But they did write this down. Let me write this over here. Let me see if I did that. Y is 4 cosine t plus 7. And they wrote the x down, which is 4 cosine t. I'm sorry. Wait a second. I think I made a mistake somewhere. And let me just take a look what I wrote down. You know what? These can be commuted around, right? So you could actually commute them around. For example, this could also be 4 cosine t minus 2, and this could be actually 4 sine t plus 7. And what am I saying over there? The order in which this is written doesn't matter. For example, you could write it as cosine squared t plus sine squared t. It's really the same thing. And you could just repeat that problem doing that. That's clearly what I did over there. All right. Number 11, we're finally getting out of the math pre-calculus stuff and getting to the calculus. So it says, use the formula to find the slope of the tangent line for the curve. Let's write this down. X is equal to, it's equal to 5t cubed. So dx dt is going to be 15t squared. All right, what's dy? I'm sorry, I'm going too fast over here. What's y? Y is 7t squared minus 9. So what's dy dt? Well, that's going to be 14t. Now, what do they want to do? They want to find out what dy dx is, evaluate it when t is equal to 3. Well, what's this going to be? I'm going to write down, dy dx now. And it's a ratio of these two things over here. So that's going to be 14t over 15t squared, which dy dx would be equal to 14 over 15t. So it's going to be 14 over 15 times 3, which is 14 over 45. Right over there. All right, let's keep going. That's number 11. And let's go to number 12. Let me sure I read that correctly. Use the formula of slope of tangent line to find. Yeah, we did that. All right, this one's a little differently, by the way. It wasn't any different. They're saying, I need to find the slope of the tangent line for the curve. Use the formula to find the slope. Yeah, same problem. Almost same problem, really is. Let's write this down. dx dt is minus t to the minus 2 minus 9 And dy dt is going to be 15t squared. Dy dx is going to be 15t squared over, I'm going to write this as minus 1 over t squared minus 9. I'm going to multiply top and bottom by minus t squared. And you're going to get minus 15t4. And at the bottom, you're going to get 1 plus 9t squared. And what do they want? They want dy dx. I got to make sure I'm doing this right, at t equals minus 3. We'll look at the key in a moment. What do you get over there? Well, minus 15 and minus 3 to the 4th power is 81. And what do you get on bottom? You would get 1 plus, well, that's 9 times 9, which is 81. So what do you get over here? 82. The top, you get minus 810 and 405. That's 1215, right? I think I did okay. Oop, I did it. It's amazing. All out of arithmetic, I got it right. That's not bad. Express the given parametric form. Let's do it. Not so bad. So what do you get over here? X equals t over 4. They want it just as a function now. And y is equal to 1/9 of a t squared minus 2t. So I'm going to solve for t. That's 4x equals t. Now pop it in over here. Nice and easy. That's 1/9. What's t squared? It's 16x squared minus 2 times 4x. I'm going to simplify it. And what do you get? Y equals 16/9 x squared minus 8x. And what do they want me to do? They want me to find y prime. And y prime, by the way, this is a function of x. Y prime, same thing as f prime of x. And what does that give me? Well, if I did that, that's 32/9 x minus 8. All right, let's see if we've done that right. And we're going to see the next page. And I just want to make sure you know that I did that, right? Yep, all done. All right, find the equation of the tangent line at t equals 1. So at t equals 1, x would equal what? Again, we're using this over here for x. That would be 0. And y, this is at t equals 1. And what's y going to be equal to at 1? It's going to be 4 minus 8, which is minus 4. So the equation of tangent line is going to be y minus a minus 4 m tangent, I don't know what that is yet, times x minus 0. Well, I got to get dy dx, and so I'm going to put down dx dt is 16t. dy dt is 8t minus 8. And let's see, dy dx is 8t minus 8 over 16t. I'm going to divide top and bottom by 8. You get t minus 1 over 2t. And I want to know what dy dx is when t is equal to 1. And that would be 0 over 2, which is 0. So this is going to be m tan now. So what do I get? Y plus 4 equals 0, x minus 0. That's an okay answer, by the way. But more appropriately, y is equal to minus 4, right? Let's take a look at the work. And I'm seeing that over here, all right? We're just doing homework, by the way. Let's try 15. What's 15? Find the point where the tangent line to the curve has a slope 1/2. All right, let's write this down. So dy, no, I'm going too fast there. Dx dt is going to be 2t. Dy dt is going to be 2t minus 3. Whoa. So what do I want? I want to know what's dy dx. Well, that's 2t minus 3 over 2t. And I want to know at what time t would that equal 1/2? I don't know. Let's take a look at it. I need to solve this for t. 4t minus 6 equals 2t. Pretty simple equation to solve. And what would you get? 2t is equal to 6, or t is equal to 3. Now, a lot of students think that's the answer. I'm not saying it's not the answer, but I didn't remember what the question is. They said find the point where the tangent line has that slope. Well, I found the t, but I didn't find the point. What's the point going to be? Just plug it in. So 3 would give you what? 9 minus 4, which is 5. And then, again, t is 3. So that'd be 9 minus 9, which is 0. See if we got it right. That's right there. So it actually, this homework wasn't bad. It was pretty easy to do, with the exception of graphing. Sometimes graphing can be very difficult, but I'm not opposed to using technology. Right? If you have any concerns or questions, I want to encourage you to come by during office hours. Thank you for paying attention.